This is chapter 10, practice test. The way it works for simplify is you're not giving me a decimal answer. If you give me a decimal answer, it's instantly wrong. Your calculator isn't going to be very much help here. It's knowing how to simplify square roots, which is looking for pairs to pull them out. So for example, right here we have two 11s. Remember that if you have two of the same number inside of the square root, they can go outside the square root. So your answer would just be 11. Over here for the square root of 8 and the square root of 18, you're supposed to factor it out to find those pairs. So like 8 is 2 times 4 and 4 is 2 times 2, 18, 2 times 9 and 9 is 3 times 3. And now you can see there's a pair of 3s, there's a pair of 2s, and there's another pair of 2s. So you have 2 times 2 times 3, so 4 times 3. Number 2's answer would be 12. Next one, you'd go square root of 12 and square root of 3. Well, the 3 is already prime, but the 12 you can factor it out. 2 times 6, 2 times 3. And then now you have a pair of 3's that are inside the square root. You have a pair of 2's inside the square root. So it's going to multiply with the 5 and the 3 that are already outside. So 5 times 2 would be 10, 10 times 3 would be 30, and 30 times 3 would be 90. Number 4, this little squared on the outside means that it's 2 square root of 10 times another 2 square root of 10. Now you have a pair of 10s, you don't need to factor them. The 2 is outside, and the other 2 is outside, and then this 10 came outside, so it'd be 2 times 2 would be 4, 4 times 10 would be 40. Last one over here, you'd go, this square, once again, means it's another 2 square root of 5. And then you'd go, here's a pair of 5s. So that's going to go outside. There's already this 5 outside. There's already this 3 outside. There's already this 2 outside. There's already this other 2 outside. And then for the square root of 12, 2 times 6, 2 times 3. There's a pair of 2's right here, so that goes outside. And then if you're real careful, you'll notice there's a 3 from 5 squared to 3, and there's a 3 that came out from factoring out this 12 that would also go outside of the radical. So all that gets multiplied together. 5 times 5 is 25, 25 times 3 is 75, 75 times 2 is 150, 150 times 2, we're up to 300, 300 times 2, we're at 600, and then 600 times 3, we have 1,800. Just in case, I want to make sure that you're prepared. I'm going to put one more example of these up here. So like, let's say that it was square root of 8 times the square root of 10. You would factor out this 8, 2 times 4, and 2 times 2. Then you'd factor out this 10, 2 times 5. You'd look for pairs. For this pair of 2's, a 2 goes outside. For this pair of 2's up here, another 2 goes outside. And if there's any leftovers, like this 5, remember that stays on the inside. 2 times 2 in this case would be 4, and the 5 would stay a 5, and that would be your final. So I'm going to call this 5A, example 5A, just because I didn't include one that didn't come out to be an integer answer. Number 6, 7, and 8. These are where you're going to be writing a fraction, and you're just going to put which letter would be top and bottom. So remember that we have SOHCAHTOA to help guide us. It's not going to be on the test. You have to remember this. You can write it down as soon as you start. The first piece, you go, okay, tangent has opposite over adjacent. So if I'm looking from angle A, my opposite going all the way across would be lowercase a, and then my adjacent would be this lowercase b. For sine of angle B, come back over here. Sine is opposite over hypotenuse. Then you go from B, my opposite all the way across is lowercase b. My hypotenuse is lowercase c. Then you do cosine of A. So you come over here, here's cosine, adjacent over hypotenuse. So from A, your adjacent is lowercase b, your hypotenuse, lowercase c. Number 9, 10, and 11. You just need a calculator, or you need a calculator app on your phone. Make sure that you can get to these answers if you're using your phone. Make sure you can get these the same as I'm getting them using my scientific calculator. So cosine of 23, I just get my calculator out. I go cosine 23, press equals. The 4 decimal places stops me at the 5. 0 doesn't change, so it's 0.9205. That's all you need to write, 0.9205. Very specific, it's got to have 4 decimal places. Next one, sine of 27, you come over here, go sine 27 equals, and then 1, 2, 3, 4 spaces. That 9's going to make this go up, so it's going to be 0.4540. And then last one, the cosine of 32, 4 decimal places, 1, 2, 3, 4. That 4 doesn't change it, so it stays 0.8480. And yes, this has to have the 0 on it to show that you're being accurate to 4 decimal places. Number 12, all the way down to 23, this is where you're using SOHCAHTOA in its traditional form. So if I'm looking over here and I want to find x first, from this angle, x is my adjacent and 12 is my hypotenuse. So adjacent and hypotenuse is cosine. So I'm going to go cos of the angle, 45, equals, and then adjacent on top, hypotenuse on the bottom. From here, this is where I use my calculator. So remember, you're always going to put the number from the fraction first. And then because x is on top on this one, you're going to multiply. And then you're going to put the cosine of 45. And then it gives you 8.5. So there's your x. X equals 8.5. When I'm doing y, and I pretend I didn't even do this problem right now, and I start with y and go, that's across, all the way across, so that's my opposite. Opposite with hypotenuse, which is the number that was given to me, is going to be sine. Then I set up my problem, sine the angle equals, and then the opposite goes on top, so y goes on top, hypotenuse on the bottom, 12 goes down to the bottom. Again, variables on top, that means we're going to multiply on this one. And just like before, first the number from the fraction, then multiply because the variable was on top, and then sine of 45, and we get 8.5. If you recognize the shortcuts, you'll remember that on a 45, 45, 90 triangle, you can go from the leg to the hypotenuse, multiply by square root of 2, so go backwards, divide by the square root of 2. You could have gone 12 divided by the square root of 2, and you would have gotten to the same answer. On this one, this is a 30, 60, 90 triangle. So if you remember the shortcut, there is a shortcut to this. You would get 8 and divided by the square root of 3. And then once you get this number, you just double it. But if you don't remember the shortcut, then you're going to have to use SOHCAHTOA. If I'm using SOHCAHTOA, I'd go from the 30 degrees, x is opposite, 8 is adjacent, opposite and adjacent is tangent, the angle goes next to it, opposite goes on top, adjacent goes to the bottom. And then again, variables on top, I'm going to multiply. So in my calculator, I'm going to go 8 times the tangent of 30. That's going to give me 4.6. So x equals 4.6. Now if you don't remember all the rules, but you at least remember the rule about from the short leg to the hypotenuse is double, then you can just go, oh, times 2, and you'll be done with that piece. If you don't remember that shortcut though, you're going to have to ignore the x answer, look at the y and go, okay, the y is my hypotenuse, 8 is my adjacent, so I'd go adjacent with hypotenuse is cosine, angle still goes here, and then the adjacent side goes on top, and the hypotenuse goes down to the bottom, and if you look, the variable's on the bottom. That means it's going to be divide this time. So in my calculator for this one, I'm going to go 8 divided by the cosine of 30. And you get 9.2. Because these problems have 2 answers, make sure you label which answer is your x and which answer is your y. Next one, I'm going to go ahead and use the shortcut. If this is a 60 degree here, that's a 30 there, so it's 30, 60, 90. From the hypotenuse down to the short side is cut in half. If that's 6, x is already 3. Now that I know that this is 3, then I know that y has to be 3 times the square root of 3. So I just go y equals 3 square root of 3. The decimal form of that, if you did it with SOHCAHTOA, with the trig function, then your answer as a decimal would be 5.2. Number 15, this is not a special triangle. This is, you have to do it with SOHCAHTOA. You have to do it with trig. So if I'm looking over here, y is my opposite, x is my adjacent, so I'm going to be using tangent on this one. Tangent tells me the opposite goes on the top, and adjacent goes down to the bottom. On the bottom, that means I'm dividing. So in the calculator, you'd go 9 divided by the tangent of 75, and you get 2.4. On this one, if I look real careful, I see that those are exactly the same. It's isosceles. So if this is 13 for this leg, then x has to also be 13. And then if I see that those are the same, it's got to be a 45, 45, 90. So I can use the shortcut and go from the leg to the hypotenuse and multiply by the square root of 2. Y has to be 13 square root of 2, 18.3. Number 17, this is a 30-degree angle right here, which means this is another 30, 60, 90. Then you can go from the long leg to the short leg, you divide by the square root of 3, and then just go 15 divided by the square root of 3. You get 8.7, and then from there, from the short leg to the hypotenuse on a 30, 60, 90 triangle is double, so just go times 2, and you get 17.3. Number 18, another 30, 60, 90 triangle. It's just a different leg over here. You could do the same process if you know the shortcut. From the long leg to the short leg, you divide by the square root of 3. So you're just going to go 10 divided by the square root of 3, and you get 5.8. And then from there, from the short leg to the hypotenuse is double, so you just go times 2, and that's 11.5. Number 19 is not a special triangle, so you can't do that. You have to go from this angle, x is your opposite, 25 is your hypotenuse, that's going to be sine. The angle goes next to the sine, opposite goes on the top, hypotenuse goes down to the bottom. This one has the variable on top, so you're multiplying it. In the calculator, you're going to go 25 times the sine of 35, and you get 14.3. Now that we have that answer, we're going to pretend we don't even have x here. And then from this angle, y is adjacent, and 25 is hypotenuse. Adjacent and hypotenuse is cosine. Adjacent goes to the top, hypotenuse goes down to the bottom. You're going to go 25 times the cosine of 35, and you get 20.5. Number 20 is another special right triangle. It's actually two special right triangles. So over here is a 45, 45, 90. And over here on this left side, you have a 60 and a 90, so it has to be 30, so that's 30, 60, 90. And if you know the shortcuts, you just go from the hypotenuse to the leg on a 45, 45, 90, divide by the square root of 2, so that means x would just be 4. Once you have that, you'd have to divide by the square root of 3 to get this bottom short leg. So you'd go 4 divided by the square root of 3. That's going to give you 2.3, but that's the short leg. You need to double that. That'll give you the long leg. So it'd be 4.6. X is 4. Number 21. X is your opposite, 10 is your hypotenuse. Opposite and hypotenuse is sine. Opposite goes on the top. Hypotenuse goes down to the bottom. This problem is going to be multiplying. So you're going to go 10 times the sine of 29. And it's 4.8. From this angle, y is adjacent. 10 is still your hypotenuse. Adjacent and hypotenuse is cosine. Adjacent goes to the top, hypotenuse goes down to the bottom, and you put it in your calculator as multiplying. So 10 times the cosine of 29, and you get 8.7. So y is 8.7. 22, same process. X right here is adjacent to the angle, so adjacent and hypotenuse is cosine. Adjacent goes to the top, hypotenuse goes down to the bottom. You're multiplying in this case, so it'd be 23 times the cosine of 51, and you get 14.5. And then you repeat the process with y, so from that angle, y is opposite, 23 is hypotenuse, opposite and hypotenuse is sine. Opposite on top, hypotenuse on the bottom. Again, you're multiplying, and you get 17.9. 23, same process, that's opposite, that's adjacent. Opposite and adjacent is tangent. Opposite goes to the top, adjacent goes down to the bottom. And then x is on top, you're going to multiply this one. 5 times the tangent of 53. You get 6.6. So now we're going to be using inverse. These still use SOHCAHTOA to help you out, so you know which ones go where, and if you're supposed to use sine, cosine, or tangent. The only difference is on these you're going to be using inverse instead of regular sine, cosine, or tangent. That's where you're going to press that second button. So like right here, if I'm looking from x, 6 is my opposite, it's all the way across. 14 is my adjacent, it's right next to it, and it's not the hypotenuse. Opposite and adjacent is still going to be using tangent, but I'm looking for an angle. That's when I know I'm going to do inverse tangent. I'm still going to use this to tell me which one goes on top and which one goes on the bottom. So right here, my opposite is supposed to go on top, adjacent goes down to the bottom. Then I put it in my calculator and I go second tangent to get that inverse, that -1 exponent. 6 divided by 14, and then don't forget, close your parentheses on this thing. You get 23.2. So x is 23.2. Next one, same thing. So you'd go from x, that's opposite. 11's your hypotenuse. Opposite and hypotenuse is supposed to be sine. We're looking for the angles, so we're doing the inverse. Opposite goes on top, hypotenuse goes down to the bottom because of sine. And then you're going to go second, sine 4 divided by 11, and you get 21.3. So x is 21.3. This last one, if you recognize that this is isosceles, these two legs are the same, you don't have to do the work. You don't have to use inverse tangent. You can just go, that has to be 45 degrees. Then there's two of them that have you solving the triangle. Solving the triangle means you have to find everything that wasn't already given to you. So like on 27, you have 2 out of the 3 sides. You can use Pythagorean theorem to find x. And you can go x squared plus 5 squared equals 10 squared. X squared plus 25 equals 100. X squared equals 75 when you subtract the 25 across the equal sign. And then you got to square root it. The square root of 75 is 8.7. If you recognize the shortcut on this thing where this is half of the hypotenuse, then that means the A's got to be 60 degrees. And then if you know that this angle is 60 and B is 90, then 180 minus 90 and minus 60 leaves you with 30 for angle C. On 28, this one, you can't use the shortcuts. So on this one, here's a long way to do things. If you have 2 out of 3 sides, you can still use Pythagorean theorem. 4 squared plus 9 squared equals x squared. And then 16 plus 81 equals x squared. And then 97 equals x squared. And then when you square root 97, you find out your x is 9.8. Now you have to find one of the angles. So from here, I go 9 would be my opposite, 4 would be my adjacent. Opposite and adjacent is supposed to be tangent. And then I don't know the angle, that's how I know I'm going to do inverse tangent. And then the opposite goes on the top and adjacent goes down to the bottom. And that's going to tell me the measure of angle A. Inverse tangent, 9 divided by 4, is 66 degrees. So now that we know that this is 66 degrees, 66.0, then the other angle has to be whatever's left over from the 180 degrees total. We're going to use 90 for B, we're using 66 for A, so if we just get that number and subtract 9 from 90, we'll find out that it's 24.0. So the measure of angle C is 24.0 degrees.